Respected ma'am, sir, my respected sir, respected sir, myself Shraddha from CSC department. My complex engineering project is basic LED blinking circuit and its design and simulation using multiism. These are the project overviews that we are going to see in this PDF. The abstract for this project is this project focuses on design and simulation of basic LED circuit using multiism software. The objective is to understand the fundamental working principles of electronic components such as LEDs, resistors, and timing devices. In this, in this study, a simple circuit is created where an LED repeatedly turns on and off, demonstrating basic circuit switching behavior. Key parameters like resistance values and timing intervals are calculated and tested to achieve a stable blinking pattern. Multiism simulation provides a virtual environment to design, analyze, and troubleshoot the circuit without the need for physical components. Ensuring efficiency and accuracy, this project serves as a foundational exercise for beginners in electronics, promoting a better understanding of digital switching circuits and simulation techniques. The objectives in this project is to design a basic blinking circuit. This means that creating a simple circuit involving a LED resistor and power source with or without a timing device like a 555 timer or simple manual switch. To understand the function of each component, study how LEDs emits light, the resistor controls the current flow, and the power source energizes the current. To select proper component values, calculate the required resistance values to protect LED from overcurrent using Ohm's law. To stimulate the circuit using multiism. Using multiism software to build the systematic arrangement of connections and perform virtual technique without physical components. To observe and control blinking frequency. Adjust timing elements to control how fast the LED blinks, such as resistor or capacitors. To analyze circuit performance. Measure voltages, currents, and timing intervals in the simulation environment to verify correct circuit operations. To identify and correct simulation errors. Debug and troubleshoot simulation mistakes like wrong wiring, incorrect component values, or missing connections. To compare theoretical and simulation results, validate the practical behavior of the circuit against theoretical calculations for better understanding. To enhance understanding of practical electronics, bridge the gap between theoretical learning and practical circuit behavior by virtual hands-on experience. To prepare for the real-world circuit implementation, gain confidence and knowledge to later build the actual physical blinking LED circuit on a breadboard or a PCB. Requirements for basic LED blinking circuit are there is no requirements of programming skills. Only the basic understanding of multiism is needed. Networking, understanding of how to set up, configure a Wi-Fi networks is a basic network understanding. Safety precautions, knowledge of electrical safety practices to ensure safe handling and installation of electrical components is a safety precaution. Hardware components, the basic LED blinking light requires an LED as the main visual indicator and a resistor to limit the current. A DC power supply such as 5-volt battery provides the necessary voltage. Additional components like 555 timer IC can be used for automatic blinking. A breadboard and connecting wires are needed for assembling the circuit. These simple components help in building and understanding the blinking mechanism effectively. Technology used, power status indicators. To show whether the switch is on or off, we need switch, alarm and alert system. Blinking of LED act as warning signs in alarm and emergency systems. Timers and counters help in visually representing timing operations or countdowns. Microcontroller project serves as output indicators in Raspberry Pi and embedded system applications. Traffic light models. Basic blinking circuits are the foundation for simple traffic light controls. Educational kits used in learning kits to teach beginners about electronics and circuit building. Toys and decorative lighting, creating flashing effects in toys, party lights, and low decoration costs. Fault indication systems, indication of errors or faults in machinery or devices through blinking patterns. Testing and debugging tools help test circuits or outputs quickly during troubleshooting and experiments. Emergency lighting systems used in portable emergency lights and signaling devices for attention grabbing. Methodology, uh, component selection, LED, resistor, transistor, capacitor, and power supply are the components used in this circuit. Circuit design includes timing mechanism, transistor switching, connection layout. Simulation setup, open multiism, place the components on the workshop and wire them according to the design. Testing and adjustment, set the value of the resistor and capacitor to adjust the blinking speed. Run the simulation to observe LED blinking. Use multiism or other tools to view the voltage across LED or the capacitor, confirming the timing and blink behavior. Verification, check result checking, ensure the LED blinking at the desired rate, usually 1 to 2 Hz for a basic design. This is a block diagram which is usually this is done in this way: component selection, then circuit design, then simulation, and then verification. Circuit diagram, power supply is connected to microcontroller which is connected to resistor, and the resistor is connected to the LED. LED is connected to the switch. When the switch is on, the power supply, then the current is passed through the resistor and the um, LED blinks. Merits and demerits. Simple design. A basic LED blinking circuit is easy to design, making it suitable for beginners learning about electronics. Introduction to components. It helps in understanding fundamental components like resistors, capacitors, LEDs, and transistors, as well as their working principles. Simulation benefits. Using multiism for simulation allows you to visualize circuit behavior and troubleshoot issues before physically building the circuit. Low cost. The components required for an LED blinking circuit are inexpensive and easy to find. Hands-on learning. It provides hands-on learning with electronic components and circuit construction. Practical application. LED blinkers are used in various applications like status indicators, alarms, and basic timers, which enhances the circuit practical relevance. Demerits: limited complexity, simulation versus real world dispectories, dependency of software, lack of advanced features, inefficiency. Overall, while it's a great beginner level circuit to understand basic electronics, it lacks complexity. As we have already seen, the component selection: LED, resistor, transistor, capacitor, power supply, these are the basic uh, things in electronics. LED is used to indicate the light. Resistor, select a appropriate resistor to limit the circuit through the LED. Transistor, a common choice for switching, is NPN. Power supply, a DC voltage source, is used in this building this circuit. As we have already seen, there is no programming skills are required to observe and control blinking frequency, adjust timing elements to control how fast the LED blinks. So demerits: limited complexity. It is a basic circuit with limited complexity which doesn't provide a deep understanding or more advanced levels. This is an easy way of understanding electronics. Simulation versus real world. Simulating a multiism doesn't always match real world behavior, as components may have tolerances that affect circuits performance. Dependency of software. Relying on simulation software may limit hands-on experience with real-world software, which is crucial for building, troubleshooting. Lack of advanced features. The simple nature of circuit doesn't allow for learning about more advanced control techniques such as PWM or microcontroller based control. The merits of this LED is it is low cost. It provides a hands-on experience with electronic components like LED, resistor, capacitor, transistor. Simulation benefits. Using multiism for simulation allows you to visualize circuit behavior and troubleshoot issues before physically building the circuit. Simple design. A LED blinking circuit is easy to design and making it suitable for beginners to learn about electronics. In conclusion, designing and simulating a basic LED blinking circuit using multiism is an excellent starting point for beginners in electronics. It provides a hands-on learning experience with fundamental components and offers simple yet effective introduction to circuit design and simulation. While it's great for grasping the basics, the simplicity may limit its application for more advanced learning. Therefore, while it's an effective educational tool, it should be followed by more complex projects to deepen understanding and skills in electronics. The references that I have took are from The Art of Electronics by two authors, Practical Electronics for Investors, Electronic Principles, and Multiism by Engineers by Thomas L. Floyd. This is my project report on basic LED blinking